Yes, saw it.
Great. So let's get started.
Yeah.
Great. Greetings for the day. I would like to welcome you all to the GIT4Beginners training session. This session has been designed for folks who have no idea what a version control system is or who have no idea what Git is. As mentioned, this session is for beginners to get to know more about version control system and why we use version control systems. And I'm going to talk a more detailed discussion on what Git is all about. And most importantly, I would want this session to be an interactive one because I don't want to put you guys to sleep in this session as is for like 1.5 hours long. So if you have any questions, feel free to ask. If you feel my voice is not clear, please let me know. So with that said, let me just get started. So I hope you guys have heard about Git, right?
Yeah.
So Git is a very powerful version control system. It's basically a distributed version control system, to be precise. And it was developed by Linus Torvalds, the founder of Linux. And he basically created Git for his Linux kernel development project. So it is an open source tool and is one of the most popular version control tools that you can find today. With that, let me just get started. So I'll give you an introduction about myself. My name is Azher Khan. I'm part of Hewlett-Packard Enterprise Helium and Cloud System project. I work as a DevOps engineer for a team called Ghostbusters. And I've been working on Git from past 2 years. Earlier we used to work on SVN. I'm pretty sure you guys would have heard this name as a version control tool. And we went on to migrate from SVN to Git. And it has been a fantastic journey, to be honest. So with that said, I just want to basically give you a brief on what the content of this presentation will have. So I have like approximately close to 80 slides. I hope I will be able to cover all of them in the session. If I would not be able to, I assure you we could have a follow-up session maybe tomorrow and maybe get done with it. So this presentation also has details about how Git functions and stuff, and I've also incorporated the commands what we use in Git. Instead of me showing you something online typing, I have captured those commands and the output results of those commands just to make sure I don't waste a lot of time. So yeah, so let's get started. So content. So I would introduce you on what version control system is and then give you a brief on how Git works. We'll give you some brief on some basic commands, branching and merging concepts, some useful stuff which I'm sure you will love, and some basic configuration and how to get started with Git. So before starting, about version control. Version control is a system that records changes to a file or a set of files over time so you can recall them later. This allows you to revert files back to a certain state, restore projects to a previous state, compare differences between files, versions, and so on. I'm pretty sure the crowd who I'm addressing right now has a certain amount of idea what a version control system is, right?
Yeah.
Yes, no, don't know?
Yeah.
Great. So I would not need to go into the nitty-gritty details of what version control is all about, right? So that's great. So, okay, another thing is essentially the changes that are stored outside your working tree in a specific location which you don't actually have access to. What this point basically means is a version control system will actually essentially have a repository stored on a particular server, ideally, and based on your access, you would be able to, work on that project or that particular repository. And the changes or the permissions given to you basically would allow you to either, make changes to the files on that repository by committing or pushing changes to that repository, or maybe you could just take a, view of what that repository contains. So let's talk about local repositories. In this configuration, file versions are stored in a specific location of your local file system. This location is created when you initialize a project, and you won't access this location by hand, but only by using certain Git commands. So this basically means that whenever you work on a particular repository, you don't necessarily talk to the database directly as a user. You basically use certain tools like Git or SVN and stuff like that, and interact with the database of the version control system. So in the case of Git, if you say git init, that basically helps you create a local repository for yourself, and from there on you can start committing files to your repository, making changes, committing and whatnot, branching and merging and stuff. And essentially you would basically do all these activities using the Git interface. All right. So whenever you say git init, and if you take a look at the folder where you're saying git init, there'll be a .git hidden subdirectory. This directory basically is where the whole magic sauce is integrated, the database and everything. All the configurations are basically present in this .git subdirectory. Likewise in SVN, I'm pretty sure
Okay.
you would have seen .svn as another hidden file, which basically captures certain database information from the client front, so that when you connect to the server, it basically fetches and commits certain changes back to the repository in the server as well. So about distributed repositories, in this configuration, files are tracked using versioning server available to multiple locals. So essentially what happens in distributed version control systems like Git is you basically have repositories in different locations. Or say you would finally have a repository hosted on one particular server, but once you clone the repository to your laptop could be as good as a backup server for the primary repository. I hope I'm being clear here. I mean, please let me know if you're not able to understand anything that I'm talking. I'm just talking to myself.
Yeah, I have just one doubt here.
Yeah.
When we said the previous slide, local repositories,
Yeah.
so in order to that, what I must have on my system?
So you need to have nothing. So I'm going to, throughout this presentation, I'm just going to talk about Git. I think I'll stop using reference to SVN because that will confuse you.
Just I thought because .git and all will be created at subdirectory.
Yes.
So any Git client or server, something must be when I say Git init. So
Yeah.
what should be there on my system to run Git init and all?
Very good question, and I think I need to pause here. So, and I'll take up the topic of distributed repositories and client-server repositories. Now, we've been seeing a lot of version control tools like SVN and ClearCase and CVS and whatnot, right? And basically, these repositories or these version control tools are functioning on a certain logic where you have a primary server which is hosted on one of the locations, and a client is installed on your laptop or on a workstation where basically you connect to the server and get information down or get repositories down, right? So that's a client-server model of a version control system. I would like and request all of you to actually forget what a client-server architecture is for version control system, and have a fresh mind to just view this presentation, because Git works completely differently than our traditional version control tools work. So Git is a distributed version control system. So when I say distributed version control system, it basically means that the repositories or whenever you basically create a repository or say Git init, that particular machine where you have just hit Git init would be the server or would be the source of repository.
Okay.
So essentially what's happening is in Git you don't basically have a client server model. Any place it could you could host Git in any place, either on a server or on your machine or anywhere. Okay, and start using it out of the box. You don't need to have a server client interaction per se. So that's how Git works. So basically you just need to have Git installed on your machine, And if you want to create a repository, you say git init, and that's it. You're done. Now you can start, creating files that you want to put into that repository. You can say git add and git commit, and it'll get pushed into your repository. And that's completely local to you. Now, if you want to share your repository and your, data to, say, your friend, who's working, in another country, you could just give the location of your laptop and your folder where you have the Git repository present, and give him access to download it, and he could use SSH or an FTP file transfer protocol and basically pull the repository down and start working on the repository out of the box.
So also he will also create the repository there, or like
No.
how okay.
Yeah, so once you say git init, it basically creates the repository for you. Now, after that, if anyone has to use that repository, they don't need to say git init. They just have to say git clone, and you pass the your machine location and your repository location to the to the destination person who wants to clone your repository, and that's it. It just gets cloned to their workstation.
Okay.
That's clear?
Yeah.
Great. So like I just said, a distributed version control system basically helps you out of the problems of what client server architecture basically had earlier. So you basically say git init and create a project locally, and you could commit and make changes whatever you want to your local repository, and you can share your repository to any of your colleagues or anybody in the world. However, having said that, working in organizations, basically you would need a central source of truth where you can actually host all your repositories, right? So for that, you can have a Git server where you have Git installed, and you basically create repositories on that particular server, and all the developers can access this Git server to access the repositories and basically push changes to that particular server so that the entire team can work together, right? Yeah, though it sounds similar to your SVN concept, but this is different because in SVN, every single time you would want to create a branch or you want to update your repository, you need to have a connection with your source server, right? In Git, you don't need to have a connection to your source server once you have done a clone to your particular machine. So with that being said, when you clone a repository using Git, you basically pull down the entire data, the metadata of your repository on your local laptop. So you will have all your branches, your tags, your entire code and everything lying on your particular workstation. And you are free to make changes, create branches, tag, do commits. And finally, when you get back to the network, you can say git push and push all these details to your source server so that your team can access the very same thing. Okay. So so let me just start this point with distributed repositories. In this configuration, files are tracked using a versioning server available to multiple locals. This server is used to sync between local repositories of various team members, thus enabling team working, and it even boosts safety as each local is full mirror of a remote repository. Okay, so this is like, this could be your server, Git server, where you have the entire database and the entire version repositories and everything placed, and you could basically say git clone to your particular laptop and make changes whatever you want, and once you feel you want to commit this particular change to the source server, you can just say git push and push to the server computer. All right. So let me just give you a brief about a Git philosophy. So Git is a version control system that acts like a miniature file system for storing changes to files over time. It's nothing more than a stream of snapshots. So let's just take this diagram for example. Now this is a time axis, where you're basically committing changes to your repository, and this is your initial version that you have committed to your Git repository. All right. So in version 1, you basically have file A, file B, and file C. And once you clone this particular repository into your machine, and say you made a particular change to just file A and you committed that to the repository, so changes to file A and C1, and you committed that change to the repository. So what happens here is Git basically computes a SHA-1 hash on the contents of your file, all right, and creates a commit for that. Wherever you see files that's not been changed, there's a link present for the previous version that essentially is marked. So what I'm trying to say is, whenever Git basically takes a particular file into its repository, it computes a SHA-1 hash on the content of the file and gives and has a key value pair of the SHA with the content in its database. So that basically gets connected into the Git server, and whatever changes you make on top of that existing file will be computed using the SHA-1 hash algorithm. So, and the file that has not been changed would just be a link, or basically this commit will basically carry the link or the SHA-1 hash of the file B that was present in the initial version. So essentially, every version that you commit into the Git repository, if you have made any changes to that prospective file, only then a SHA-1 hash would be computed, and a key value pair would be generated, and that would be linked to the Git's repositories database. And if there's no changes to a file, the SHA-1 hash that was generated earlier for that particular file would be linked to your commit history, or your commit message essentially. So, I mean, is this clear?
Yes.
Hello?
Yes.
Yeah. So over time, this is what happens. You basically have a link if there's no changes to the previous file, and if you have made any changes, a new SHA-1 hash would be computed, and that would be a part of your each commit. So yeah, I'll just give you a brief about what working directory is versus the repository. So the idea behind Git is to decouple the working directory from the repository. So when you say git init and you have your Git repository present on your particular machine, you basically have the entire database being present and is available for committing and whatnot. And whenever you want to make changes to your repository, you basically do a checkout to your project. And when you say checkout, it basically you do a clone to your machine, and whatever changes you make would be present in the working directory. And once you think of staging the changes, or say you choose to commit certain changes into your repository, before it goes into a commit, it will go into a staging area. And finally, whatever contents are present in the staging area would eventually be committed to the repository. So the repository, as I said before, is the place where all the snapshots of your files are stored. Definitive changes in your files are saved essentially in the repository. And the working directory is a temporary mirror of one specific snapshot. So the developers, to code and test on. And no deploy is made from the working directory to the repository without users intervention. Checkout. So when you start coding, you basically make a checkout of your local repository, and this simply copies the files from a specific snapshot of whatever you have. You could just branch and basically do a checkout, and that basically would be available in your working directory. And you could basically make changes on your local repository, and finally, push or say git add to add that particular changes into your staging area. And essentially the working directory is a location where you can safely make changes to whatever features or bug fixes that you're working on, and this operation lets you to safely code on the working directory without affecting the repository per se. So the staging area was a stage essentially is after you have made some changes, modifications, and once you're satisfied, you want to push the changes into the repository, or before you commit, you basically stage the changes into the staging area. So first of all, you stage modified files you want to push into the repository to staging area, and no changes are made to the repository yet at that point of time. And finally, when you're ready to basically choose to make a commit, the contents that is present in the staging area will get landed into the repository when you say a git commit. And this is the point when a new snapshot is created into the repository, and only stage files are committed. If you make further changes on the working directory without staging them, they won't be committed essentially. So is this clear?
Azher, one question here. So
Yep.
is staging area a must? We need to have a staging area to do a commit, or we can do commit directly to the repository itself?
No, you cannot. So you have to have essentially Git works on a logic, or works on a practice where you basically need to choose the changes that you want to commit into your repository. All right. So I can take an example here. For example, say you're working on, say, a project on Linux kernel development, and you're doing a bug fix for them, right? So what you do is you can just create a branch. First of all, you clone the repository into your laptop, right? Then you create a branch for the fix, and you start coding the changes onto that branch, right? So whenever you want to basically add or push changes to the repository, you would need to say you would need to add that changes into the staging area. So why we have a staging area, if you may ask, is basically to ensure that you select only certain changes that you want to push into the repository. Now, for example, like I said, imagine you're working on this bug fix, right? So you would start coding and solve the problem to bug fix with respect to the bug fix, and say you choose to commit this into the repository. You can just say git add, and that particular content will be placed in the staging area. Now you could also continue to maybe write another feature on top of that particular commit or fix, or maybe you can fix another fix that you see would be a problem, and just leave that alone in the working directory and don't commit it, right? So here you have two changes in your one branch. One is a bug fix that you are working on, and one is another fix that you think would is good to merge into the repository. So you can selectively choose what you want to push in for that commit by saying git add and adding that content to the staging area and committing that changes. And once that change is committed, you could still go back and pick up the stuff that you have not committed, which is another fix, and you could push it as a second patch set to commit into the repository.
Okay. So this staging area is where it gets created on its own, or we have to invoke some commands to get it created. How is it kind of made available?
Okay. Essentially, Git. This concept basically Git's concept. So Git basically has a buffer, which is a buffer allocated for staging area. So whenever you say git add, the content that you want to add will be pushed into the staging area automatically. So there's nothing that we have a manual, there's no manual intervention involved while adding files to the staging area. And yes, you have to basically stage changes that you want to push into the commit. Without without staging the changes, you cannot push the code into the repository. So it's a must.
Yeah. Okay.
Right?
Thank you. Yeah.
Okay. So I'll just talk about more in detail about the Git stages. So at the end of the day, you just need to remember that Git allows files to exist in one and only one of those stages at any given point of time. So once you have cloned the repository and you are about to go make any changes, when you say git status, it says nothing to do. That basically means that you just have, you just have the base of the repository with you, and there's no other changes that are currently present, right? So the different stages in Git when you basically, when you're basically working with Git. So one is committed. This means the files has been safely saved on the local repository. Another stage is called modified. The files in modified stage, the files has been modified but not yet committed or staged. And staged is the phase where the files has been marked to be committed in the next commit operation. So I hope this simplifies or answers your question, Salib. Right? So this is generally the typical workflow. So you make a checkout of a local repository to have a fresh copy of latest snapshots on your working directory. And then you make some changes on a file on your working directory. Then you stage that particular changes, by saying adding a snapshot of it to your staging area. And finally, you commit those changes, whatever staged in your staging area, to your local repository.
Yeah.
Okay. So now I'll give you a detailed walkthrough on the full life cycle of how changes, are traversed, and at what phase, where the change would basically be located in terms of stages. All right. So like I mentioned before, there are basically 4 stages. One is your untracked stage, where basically that particular file is not being tracked by the repository itself. All right. An unmodified phase where you have nothing to do. Like I said, when you say git clone and you have the repository cloned into your laptop, when you say git status, you have nothing to do. So that's an unmodified phase. And another stage is modified stage, where basically you would make changes to the files that are already present in the repository. All right. And stage is the phase where you would choose to commit certain changes or certain files into your repository. So that's the stage. So this diagram basically summarizes the stages a file must have when it's in the working directory. The story begins with the tracking state. So a file is said to be tracked if there is evidence of it in the last snapshot in the local repository. All right. On the other hand, it is said to be untracked if no story of it is available. For example, like I said, new files or files that need to be committed yet for the first time. So when you say git add, or you add a particular file into your repository, you need to add you'll basically be tracking an untracked file. So it goes into the untracked state directly to the staging area. All right. And it will be added to the repository during the next commit. So like I said, if you have a new file that you want to add into your repository, you basically, that file will basically be in this stage first, in an untracked stage, right? And then when you say git add, this particular file will be pushed to the staged area, where the file will be picked up for the next commit. And when you make a commit, staging area will flush the files in the working directory and goes to the unmodified stage. This is because files in the working directory are identically the same on correspective in the repository. Only the file in the staged area gets committed, thus reaches the unmodified stage. Files not committed will preserve their states. And then when you basically make a modification to that file in the working directory, it goes into the modified stage. This is because the file is in the working directory and doesn't have much doesn't match with the correspective in the repository. So modified file won't be automatically staged. You must manually stage it if you want to basically commit it. All right. And then again, so from the modified phase, when you make a change to a particular file that is already present in the repository, you basically edit it, make changes, and you save it, and say git add, and again it gets pushed to the staged area. And all files from the modified stage can be staged as well. So once you have the files in the staging area, these files are basically chosen or selected for the next commit. And that's one phase. So then another phase is basically when you have to remove a file, right? So when you remove a file from the repository, the file will be pushed out of the repository and thrown into this untracked stage. So removing a file from Git won't automatically delete it from the working directory. It either doesn't tell Git to ignore the file, but just pushes to untracked stage. And you can always add the file again because you already have the snapshot of the file present in the previous history. I hope this is clear with you guys. Okay, I'll move on. So let me just get down to some basic commands. So the Git command line, Git basically comes with command line tools to access its virtual file system, and it's available for almost any operating system. So you could, I have shared some links with Sandeep for installing Git. You could also Google to install Git, and if you have a Linux Ubuntu machine, you can say apt-get install Git, and you can have it downloaded onto your Linux machine. You have various ways of interacting with Git with Windows as well as Mac. And you can just Google for that, and maybe I could just share you the links at the end of the presentation. By any chance, any of you guys have installed Git into your machines?
No.
No? Okay.
Yeah.
I would encourage you to install it and play around with it. And if you have any questions, maybe you could ask me, and I'll see if I could help you out with that. So yeah, there are many different graphical tools that are available which are pluggables with Git. But for the sake of knowledge, I just want to stick to the command line interface because that's the most common way of accessing with Git, and that's the only way I have been accessing or working with Git. And it gives you a better picture on how Git works under the hood using the command line interface. So to invoke a Git command, you just need to call the Git executable followed by the command that you want to execute on. So we'll take some dig on the most important commands and details later on. So getting a Git repository. You can start working on a Git repository in two ways. Like I mentioned earlier, you could actually say git init and have a local repository created on your particular workstation itself. Or you could choose to clone a repository that is already existing out on the internet. That could be either your own hosted Git server in HP, or it could be GitHub or Bitbucket or anywhere else outside. So initializing a repository into an existing directory, basically this puts a directory from when the command is triggered, and its subdirectories under version control. So say for instance you want to version control a particular directory of say code that you have on your machine. You could just cd to your directory and say git init, and then go ahead and say git add and commit, and that's it. You have your folder right now under version control. So that's the beauty of Git. It's extremely fast, it's extremely portable, and you don't basically need a hosted server to host your version control system or your repository. You could use your machine itself to host a repository. Yeah, so any questions here?
No.
Okay.
Azher?
Yeah.
When we clone the repository, that example you have given, git clone.
Yes.
So the target repository name by any chance should be same, or we can choose our own?
Okay.
I should try out, I know, but I'm just...
Yeah, no, absolutely not. See, so whenever you're cloning, you're essentially trying to ask whether when you say git clone, can I mention whatever name I want as a folder where the content should be cloned? Yes, absolutely. You could choose whatever name you want. All right. So once you have done a git clone or say git init, right, you basically see a .git hidden directory. When you see that directory, you can clearly understand that that particular folder is basically under version control.
Okay.
So yeah, another most important command that we use very often is the git status command. So it is used to check the status of files in the working directory against their version, in the latest snapshot of the local repository. So I've given a few examples in my slides itself just to save time. So let's just dig into a typical output. So when you say git status, this is what you see if you have say a file, a new file has been created and you have made some changes to an existing file. So it basically says that, when you say git status, it says on branch master, because that's a default branch referred by Git. So whenever you create a repository, by default, it will be pointing to the master. All right. So it also says here that changes to be committed. You basically have one file that is new. Okay, and it says changes not staged for commit, and this basically means that there's one file that has been modified. So here this basically means that we have a new file and we have added this file into staging area to be committed, and we also have a file that was already part of the version control system, but we have made some changes into it and we have not staged it into the repository. Is that clear? So this basically suggests that at this point of time we have two files, okay, that is readme and contributing.md, wherein readme is a tracked file, okay, untracked file in untracked state, and the contributing.md is in an unstaged state. Is that clear? Are you clear with this?
Yes.
Yes, sir.
Yes.
So after this phase, what basically happens is I'll just show it in a pictorial representation and how we basically move these files into the repository and how we can move around with it. So the same git command is used to track an untracked file and to stage a modified file. So essentially you say git add the file name to basically stage it into your staging area. Okay. And in the previous example, like I showed, when you say git add, this basically brings that file into your staging area. So when you add a new file, when you have a new file in your repository, you basically need to say git add to add it to a staging area. All right. And when you have an existing file and when you want to basically capture the changes into capture the changes that you've made into that particular file into your repository, you say git add contributing.md to stage that working copy of this file contributing.md, which underwent some modifications from the last checkout. All right. So getting the status after the staging would basically have, when you say git status and when you say git add readme and you say git add contribute.md, would basically add both the files into the staging area. All right. So as expected, Git is suggesting that two files has been staged. They will be pushed on the local repository during the next commit. Any further changes made to these files after the git add command will not be committed. These changes would end up into a new, not yet staged version of the file, and this would held into the apparently counterintuitive behavior of files being marked as staged and unstaged at the time. So this basically means that when you have two files, if you want to add them to the repository, you just say git add to it, and these files will be pushed into the staging area. All right, and the different ways of interacting with Git, to find the status of each file and to know whether the file has been modified or whether the file has been modified and added to the staging area or not. So these are the phases that I've just captured a few. So so a better way of finding the status of a particular file is using git status -s command. So here you can see on the left hand side the column indicates that the files are being staged, and the right hand side you have indicates the files being modified. So when you see readme file with a capital M, this basically means that this file was modified but not staged, and it will not be committed because we basically commit files that are already in the staging area, right? And for libsimplegit.rb file, it says was modified and then staged. It will be considered for commit. And for the rake file that you see mm, right? It basically means that the file was modified and staged, and it will commit. Then this was modified again. These changes will not be committed. All right. So for libgit.rb, the file was just added and staged, and it will be committed. And for the license.txt, this file was not been added and has been marked as untracked and will not be committed. So these are the various states or stages where a file would be present in the Git repository, and this is what the left-hand side column basically represents what state they are currently present in. So Git.
Yeah. Sorry to interrupt. One question here. So every time we want to do a commit, we have to add. So every time I have to do git add to add the changes that I want to commit, and then only I can commit. Is that right?
That's correct.
Okay. So basically, I have to run 2 commands to get something into the repositories.
That's right. There's also a shortcut of basically adding and committing at the same time. So instead of saying git add file name and then saying git commit the message, you can just say git -a-m.
Okay.
Sorry, git commit -a and commit that file into the repository without adding. I mean, essentially it means it'll git add under the hood as well as commit at the same time. So instead of you passing 2 commands, you can just give the -a option to add the file automatically.
Okay. Okay.
All right. I mean, yeah, we'll just go through those commands in a short while.
Okay.
All right. So viewing changes. So git status only tells you if a file was modified or not, but it won't show you what actually has changed, right? So to see what has been changed into a file, you would need a diff command essentially. So Git has its own diff command, which will help you find out what are the changes between 2 commits, or what are the changes between the staging area as well as the previous commit, and also what are the changes between what you have in your working directory and the staging area. So Git is like extremely powerful. So that way you could actually identify, what changes you're trying to commit, and what changes you have not added to the staging area, and whether if you want to choose to add, the untracked files or untracked changes into the staging area or into a commit as well. So yeah. So it will show you the difference between Git basically show you the difference between the contents of your working area and the content of the staging area. In other words, it shows the changes you have made that you made to the staging area and has not yet been committed. Similarly, the command git diff "staged" option compares the content of your staging area with the last commit. In other words, it shows the changes in your staging area that you haven't yet committed. All right. So very often developers prefer to use an external graphical tool to dig into diffs. So we have a lot of tools like Git for Linux, and I think GitHub has its own tool for Windows, where basically you could get the look and feel of of using something like an SVN interface, if I may say, with Git. But generally, I've been working on CLI. And when you just say git diff, it gives you pretty good enough information for you to decide what changes you want to capture and what changes you want to commit to your repository. So finally, when you have staged your changes into your file, into your staging area, the last step is the commit phase. So the command for committing any change from your staging area to the repository is by using the command git commit. So you can say just git commit and get done with it, but it is a good practice to have a git a commit message as part of your commit. So that's the reason why you use the -m option to basically carry the message of the commit. And like I said, you could also choose to add and commit a particular change from staging area to the commit to the repository. Bypassing, the -e option, and removing files. So to remove a file from the repository and the working directory, you cannot simply delete from the working directory, as it will still be marked as tracked file. So to remove the file completely, you would need to use a command called git rm, the file name, and this command will basically mark the file as untracked and then delete it from the disk. And if you want to keep the local copy of the file, you can use rm-cache and use a file name, and this basically will put the file into untracked and ignored state, but will not delete the file from the disk. So I hope you understand the difference, right? Okay. Right. So the next another command is git move command. So you would also find the need of say renaming the file, and you could use git mv, the source, the existing file name, and then the file name that you choose to rename the file to. And once that's done, you can add the particular file by saying git add, and then commit it into the repository. So essentially, the most common thing is whenever you make changes to a particular fix or a particular file, there are a lot of times that you would have realized after committing that these changes are not as per your satisfaction, or you want to make changes to your existing commit once committed to your repository. So Git has a way of amending commits, and like the word itself says, you could use the command git commit --amend to basically make changes to the existing commit, and this will basically help you rewrite your commit history and rewrite your commit content as well. So whenever you realize that you have messed up some commit, you could safely rely on this amend command. All right. Do you have any questions here?
The amend option will just only amend the latest commit. So you have no way to amend the commit that is not the latest one, right?
That's right. That's correct. So git amend commit amend will basically amend the commit for the latest commit itself. It does not have the power to commit amend changes of the older commits.
Okay, so there's no way, right? Whatever I want to change the commit description, maybe in the earlier commit, there's no way in Git, right?
I'm sorry, could you come again?
I mean, there's no way that if I want to change the commit descriptions for the earlier commit, not the latest one. So there's no way in Git, right?
Yeah, there's no way that you could do that. So you could write another commit for that change. Okay. But see, it's a good practice to ensure that you don't rewrite commit history of your previous commits, because you want to make sure you maintain consistency and you track each and every version that's that's been committed, right?
Yeah. But in Subversion we have a way to change the commit descriptions, right?
That's right.
Yeah.
That's right. But here, I mean, it's like a best practice, if I could say. That Git wants to enforce people to follow. So that way, it just helps you to track whatever has gone into the repository, and people, no matter how powerful, whether the admin user as well, does not have the authority to make changes to the previous commit. That's one. That being said, even the way Git works internally, right, will not allow you to make a commit change to say to any commit before the latest commit. That's because, like I said before, whenever a file has been committed or a change has been committed into the repository, right? So Git computes SHA-1 hash on that content, right? And creates a key value pair in its database with the SHA-1 hash that it shows to you with the content mapped to it into the database, right? Now you can no way go and rewrite that data into the Git database. Okay. I hope you understood that, right? Okay. So every commit, like I said, has a SHA computed on the content of each file. Mm-hmm. So you can't go make changes to that content to say a commit which was 3 commits before the latest commit. So that means the commits that have gone after those 3 commits would also have to be rewritten. So if I have to summarize this, what I could say is I had a situation where one of the developers had committed a ISO into the Git repository, mm-hmm. and later on we found out that this ISO was 500 MB, and it was eating up, of course, all our network bandwidth, and was slowing down our Git server. So we had to remove that particular file from Git. Though we used this rm command and said remove out of the Git repository, this command basically removes the file from the Git repository for that commit, but it does not remove the file from its history. I hope you understand the difference, right?
Yeah.
Yes.
Yeah. So when we had to remove the file from its from the actual version where the file had been committed, right? We had to rewrite the entire history of Git from that commit on. So it was like 30 commits down where that file had been committed. So we had to use tools to actually remove that file from the database, and Git automatically had to rewrite each and every commit on top of that. And after that, our repository was, quite unstable. So we don't basically recommend that. And even I've seen online, there's no direct way of making changes into the Git's previous commits. You could, but if you have an ISO stored in, it basically creates a lot of complexity. All right. I hope I answered your question.
Okay. Yeah.
Yes. All right. Yeah. So another phase is if you realize that you have staged the wrong file, by saying git add, and you're trying to basically commit that particular file, and then you realize that you have the wrong file that's been staged. So you could safely use the git reset head command with the file name to remove that file from the staging area. So when I say staging area, it basically means you had made changes to a file and you said git add, and that file got moved into the staging area. And when you are about to commit, you realize that you want to remove that particular content, whatever has been changed to the file. So there you could use git reset head command with the file name. And if you want to basically remove that change completely out of your working area, working directory as well, then you can use the --hard option as well. So the command would read git reset --hard head and file name. So whatever changes that has been that you have added after the file had been cloned in your repository, all the changes will be gone, right? So this is a pretty powerful command, so just be a little careful when you're using it. Okay, so if you realize that you won't need to keep changes that you have made to files from the last checkout, you want to redo from start, from say latest snapshot, that time you can use the git checkout --in the file name. So this basically will perform a checkout for that particular file only. All right. So just be careful that this will definitely override the local versions of the file as well. And also remember that anything that is committed is almost always recoverable. Like I said, even if you commit any file and say remove it after a while, you still will be able to get the contents of the file from this previous or the older snapshots. But anything you lose that was never committed is probably lost forever. So when you use like git checkout --file name, it'll remove all the changes that you have made in your working area as well as your staging area. All right. So any questions so far?
No.
Okay. Is everything clear so far at least?
Just one question, Azher. So far, whatever things we have seen, was applicable to the local repositories, like.
Yeah. Yeah, that's right.
Yeah.
I mean, when you say local, what do you mean by local repository?
Local means either I have created, I have code using git clone or git init.
No,
So
it doesn't matter whether it was you've done.
Yeah.
Okay.
Yeah. So this checkout, add, commit was happening to my local repository.
Okay.
Right?
Yes. Well, yeah. So when you say git clone or when you say git init, right? essentially you have the repository in your laptop or in your work
Yes.
area, right? So whatever changes you make will be, whatever changes you make, and you say git add and you say git commit, it basically commits your changes into that particular repository.
Yes. Yeah.
So if you have, say, git cloned a repository, all right, and you want to push the changes back to the GitHub repository,
Yeah.
after you have committed, you need to say git push to push the changes into your
Oh, okay.
remote
Okay.
repositories.
Yeah.
So that's the next topic. I'm going to talk
Okay.
about remotes,
Yeah.
and maybe that will cover most of your questions. So far, at least, I hope you were able to understand if you don't have a Git repository, how to create one.
Yes.
And if you have created a repository, either to clone it or using Git, you can create a repository or use a repository, and you know how to make changes to this repository, whether to add a new file into the repository, how you need to, what basically you need to follow, or how to make changes to the existing files in the repository, and how to push the changes into your staging area, and choosing what changes you want to commit from the staging area to the to commit the change into the repository, right?
Yes.
And also I've given you commands on how to rename the file or remove the file, or remove the changes from the staging area, or remove the changes completely from the working area, and all the stuff. So far we just covered all that. All right.
Yes.
So now we'll move on to something called working with remote repositories. So remote repositories are versions of your repository hosted on the internet or any network. All right. They are centralized and accessible locations, give you the possibility to collaborate in teams. So a best example would be GitHub, right? So GitHub is essentially an application where you can host your repository for free. Essentially, open source repositories are basically stored for free and accessible to public all over the world. All right, so you may have many of them, some of them with read-write access and others with read-only access. Depending on your grants, you can pull data from the repository or eventually push data on it when you need to share your work, right? So in GitHub, that's the whole concept. You can actually give permissions for some people to read-write, give read-write access to the repository so that people could clone as well as push changes into your repository. Or they could just have read-only access where they could just clone and just make changes locally in their own machine, but they don't have access to push those changes into the GitHub or a remote Git repository. All right. So the popular examples are GitHub and Bitbucket, and they're pretty fantastic. And I think by now you would have heard at least about GitHub and Bitbucket, right? Has anyone got a chance to work with GitHub? Okay, I assume no.
Just took some repositories from them.
Okay, great. So they're pretty popular ones these days.
Yeah, we worked with Stash.
Stash?
Yeah, it's commercial version of Bitbucket, I think.
Oh, that's awesome. That's great.
It's the old version of Bitbucket. Before Bitbucket, it was called Stash.
Yeah.
As far as I know.
Oh, okay, great. So, let me just talk about some cloning the repository. So, when you start contributing to a project, or when you init a repository from GitHub or similar, the first command you basically use to trigger is the clone command. Okay, as the name itself suggests, clone basically clones a remote repository into your working area. So when you say git clone and the command, and the repository URL, this is the exact activity that happens in your local location or on your workstation. All right. So it basically connects to the HTTP, this GitHub.com, the Clue Analytics Vagrant.git project using the HTTPS protocol, and pulls down the remotes and all the pack objects in the deltas to your workstation. So once you have the repository cloned from GitHub, you basically need to you can basically check the remotes that are available for your use. Okay, so when you add a remote, you basically link a local repository to a remote one in order to be able to take them in sync. So when you basically do a git clone, like I said, and whenever you want to make changes or submit changes to this particular repository, you need to have a remote enabled. So when I say remote enabled, it basically means that you should be able to point your repository to the one that has been hosted, to either sync the repositories from both ways, whether you want to pull down changes from your remote server to your laptop, or push changes from your laptop to the remote server. All right. So you can also have more than one remotes connected on to the same local repository. For example, you may have a production read-only remote repository to fetch data from, and a dev read-write repository to push your contributions from. Right? So to list all the remotes you have for the local repository, use the git remote -v command. So this basically shows the remote that is by default the origin, and this is a URL that we cloned from, and it says for fetch and push purposes this is the URL to use. All right. So when you clone a remote repository, like I said, a remote called origin pointing to the source of the clone is automatically added to your local repository. All right. So I hope you're clear with this, right? So you know what's a remote and what is its function. Yes. Do you know? Do you don't know? You have a question? You're confused? Let me know.
Yeah, so Azher, I think this is similar to one of the use case that we have is like we have we have sources in a repository which is hosted in GitHub, and we want to create a local replica of it of that in CTF, basically Team4, and then periodically we will do pull from the GitHub repository.
Yes.
Changes, and then again we'll make local changes and do a build. So is it the similar thing?
Yes, that's right. It's similar, but you would need a mechanism to sync changes between your repositories. So I mean, to automate the process of ensuring that you pull down the latest of what is present in the GitHub for that project, you would need to write some automation in your Git scripts. All right. So, but essentially, this is what you'll be using. You'll be using a Git remote to connect to that particular repository for fetching the changes from that GitHub or pushing the changes to that particular GitHub repository.
Okay.
All right.
So, Azher, is this the master repository it is listing, or it's something else?
See, essentially, say for example, you're doing development on Vagrant. All right.
Mm-hmm.
So there's the repositories that has been hosted by GitHub for Vagrant are many, right? All right. So imagine you want to basically make changes to one of the Vagrant repositories. So the link that you use to clone that repository would be the remote that will be added to your local to your working area. Okay. So the whole purpose of using remote is for say multiple parallel development. Not just that you can create a remote to sync changes between your between the changes that you have on your laptop to the remote server. You could also have say local development of Vagrant in your own organization, and you would want to have another remote to that and make changes internally for HP. Are you getting what I'm saying?
Yes.
Yeah. So essentially, remote is for that. So
okay.
you can create multiple remotes. Like for example, like I said, Vagrant development may be in open source, Vagrant development may be in HP. So you can have two remotes: one remote for HP development, one remote for open source development. And you can sync changes between these two remotes and submit and push code and sync code and everything.
Okay.
All right.
Yep.
Yeah, so to add remote, like I just said, add or remove, you can use the remote add command. So yeah, like I said, you could add multiple remotes for the same local repository. Each of them is identified by name and points to a specific URL. All right. So origin is just the default name for the remote automatically created when you clone a remote repository. As fact, you may change or even delete it if you don't need anymore, right? So using the git remote add command, you can actually link a remote to a particular URL. And you can give whatever name or whatever remote name that you want. Like for example, here you've given Andy to create a remote for this particular repository. All right. So similar to that, to remove a remote, you could just use the command git remote rename whatever name you want. Git remote and just give the file name and the remote name, and that will remove the remote for you. And to rename the remote, you just say git remote rename the existing remote name and the new name, right?
Okay.
So yeah, interacting with remotes means to be able to get data from them, and if you have to grant to do so, to push your contributions to it, right? To get data from your remote, you basically have to use two commands. One is called git fetch and another is git pull. So, like I said, once you have cloned a particular repository, like say Vagrant repository from GitHub, now you have remotes connected or linked to the open source GitHub repository, right? So you need to make sure that you pull down the latest changes from GitHub to your particular repository, right? So how you do that is basically using these two commands. So git fetch basically means you fetch the changes from the remote repository to my local repository, and that's it. Don't do anything else. Just fetch the changes. All right. When you say git pull, it basically means a git fetch and a git merge. That means it says pull the latest changes from the remote repository to my local repository and merge these changes to my local repository. Right. So the definition is when you fetch data from a repository, you are asking Git to download data from the remote to the local repository. So data is downloaded but is not merged, right, to what you're working on until you merge it to the local branch. So the command is like this: git fetch the remote and the local branch. And if you want to fetch and merge data automatically, you are basically making a pull. Okay, the content of the working directory will be updated to the latest snapshot of the remote repository. The format of the command is similar to this. You say git pull the remote and the branch name. All right. And once you have pulled the changes to your to your workstation from the remotes, you could create your own branch and make changes that you want to. If you want to contribute to this particular project, you basically need to commit those changes locally to your repository and then push the changes to the remote. All right. So this is how you do that. On the other hand, to deploy data to a remote, you just have to use the command git push. And of course, you need to have permissions to edit to the repository. Only then your git push will be accepted. All right. So when you push data from a repository, local commits are uploaded to a specific branch of the remote. So the command would be this: git remote, git push the remote and the remote branch. So when you say this, it basically pushes your local commits to the remote branch that you have defined. All right. So it's important to note that the push will fail if someone else has cloned and published the remotes in the meantime. This happens because your remote repository is non-consistent with your due to her contributions made meanwhile. So what essentially this means is whenever you have to say push changes to the remote repository, you need to make sure that your local repository has the latest changes on top of your commit. So during the phase where you have done a git clone, okay, and you have made your own development changes and stuff, if someone else has committed or pushed the changes into that remote repository, when you say git push, that push will fail because you need to make sure that you pull down the latest and the greatest of the remote repository down to your workstation and amend your commits to that particular on top of that particular commit, and then push it finally into the repository. So is this clear? I am expecting some questions here because this is
Yeah, sir, just one doubt here.
Yeah.
Probably the remote, the project on the GitHub they release version every 1 month.
Okay.
So I just wanted to, when I do pull, so that time only that new version will get downloaded, or how, or we need to explicitly mention what we need to pull.
Okay, so when you say git pull the remote from the
We
remote,
go back
right?
to the previous slide.
Sorry?
That command, previous slide, that command was also there. Yeah.
Git fetch?
Yeah, this one.
Tell me.
Yeah. So when we do fetch or pull, so probably last month the version available was 8.1. So now for in Git Hub they have come up with the new version 8.2. So I wanted to consume those changes. So in that case, when I pull, what I will mention? So I will mention the new version. It will be a separate branch, or how?
Okay, so essentially you would, whatever release happens essentially happens on the master itself in the open source projects. All right. So like the development that you will be doing or you are doing on your local Git repository, likewise the same development happens on the remote side as well. Okay, on GitHub as well. So whenever you say git pull, after you have done a git clone, whatever is the delta between what you had cloned to what is present at that point of time when you say git pull will all be fetched down to your local repository and merged. So all the changes that have gone in from the time you had said git pull to the time you had said git clone to the time you have said git pull, all the changes that are there in the remote repository will come down to your workstation.
Okay.
All right.
Yeah.
Great. Any other questions?
Yeah, sir, I have a question. Basically, say I do not have the permission to push my changes onto the master or the actual repository. Yeah, remote repository. In that case, what will happen? I will say the author of the repository had set a permission that I need to review all the pull requests that is coming to me. So is that possible?
Correct. Yes. So you're talking something with reference to forking and pull request.
Right.
So in GitHub, the concept is a little different than what I have all spoken so far.
Okay.
So here I have just mentioned you say git clone and you say git fetch and you say git pull and then you make changes and you say git commit. It gets pushed to the repository, right? And that happens in a world of Alice in Wonderland where everything is all good and you all have access to everything, right? But that's not the case everywhere. So let me take an example of Linux kernel development project, right?
Okay.
So Linus Torvalds basically manages this project, okay? So when you want to contribute to this particular project, Linus does not know you, right?
Yeah.
So what you would do is you would fork that Linux kernel development project, all right? So when you say fork, GitHub will clone that repository, the Linux kernel development repository, to your name, all right?
Okay.
And then you could clone this particular repository from your ID and to your workstation, all right?
Yep.
So once you have it cloned to your workstation, you can do whatever changes you want. Like you said, you wanted to maybe add a feature to Linux kernel development, and you commit it locally and you push it. All right. So this push will go into your repository. All right.
Okay.
So once that's been done, when you log into the GitHub page, right, you will be given an option saying submit a pull request.
Okay.
So when you click on submit a pull request, it will show the delta between the changes that you have committed and to the changes that is present in the repository, and will be sent to Linus.
Okay.
And Linus will then review your changes, and if he feels it is good, he will push that change into the Linux kernel development project, and that's how it will get merged.
Okay, got it. So it's specific to GitHub. It is not available in the other versions of Git.
So now this what I spoke to you was with respect to GitHub.
Okay.
All right. So there are many different ways of working with Git. Some people we use Gerrit. All right.
Okay.
Okay. And other people they just host it using GitHub. So there is two ways of doing it. If you want to work with a team, all right. If you are working, say, in the silo where you just have maybe 4 or 5 developers, and you trust each other, that time you can just have one of your laptops as a Git server, and you could make sure everyone clone from your laptop and push changes to your laptop.
Okay.
And you can just monitor that, because as a small team you would know what the changes are going in, you can talk to each other and solve it. But when it comes to open source development, you have like thousands of developers working together, right? So you need to have some sort of workflow defined to ensure that changes are pushed to a repository through a well-defined workflow.
Okay.
With access restrictions and stuff. So that's when we use Gerrit and GitHub essentially.
Okay.
Yeah.
Thanks, Azher.
No problem. I hope I answered your question.
Yes, definitely.
Great. Any other questions so far? Okay, I'll take that as a no. All right. So the next concept is branching and merging, and this is like the fun part. So in Git, essentially, we treat branches as a very small thing. I know in the SVN world and ClearCase world, when you say branch, it's like one request coming to a team where they create a branch with all preparation and stuff, right? And in Git, branch is nothing but a simple pointer. That's it, nothing else. And Git basically pushes or encourages the model of creating as many branches as you want, because it's just a pointer that you're creating. You're not creating a whole new snapshot. All right. And the purpose the great thing about creating a lot of branches for development is not just because it'll help you isolate your work or make you do parallel development. It will also help you work on multiple things at the same time. That's why we have branching, right? And at the cost of nothing, because the speed of shifting from one branch to another is lightning fast compared to what you would see in SVN or CVS. So before going to that, I just want to give you an anatomy of each commit. All right. So before introducing about what branching is and how it is useful, we need to take a step behind and talk about how a commit actually works. All right. So as I said before, a commit is a snapshot of content in the repository, right? But it's very important here to note that each commit has a pointer to the previous one. Altogether, they form a linked structure like a chain. So Git basically, if I may say, it's like a huge doubly linked list. I hope you guys are aware of linked list, right? So everything is a pointer in Git with respect to referencing histories or branches or tags or whatnot. Everything has a pointer to it. So here, if you see the first commit, when you say git init, and there's you have nothing else in your repository, just an empty directory. When you commit for the first time, what you see is that the parent will be blank. That basically means that this is the initial commit. All right. So each commit carries information as mentioned here. It has a commit size. It has the tree SHA. That basically means the name of the file name that is part of this commit, along with its SHA, and the author who's committed, and the committer name, and the commit SHA itself. That's 983A9. All right. So when you push another commit, say you have a second commit, right? So this would look something like this. You would have a commit ID like this, 34AC2, and you have a commit size. You have a commit tree SHA that's been created, and the parent SHA is is basically the SHA of the previous commit. So I hope this helps you understand how Git is functioning internally, right? So I had made a statement a while ago saying that whenever you say Git commit or when you say Git add itself, okay, what happens is Git is computing a SHA-1 hash on the content of your file or of your change, right? So that, and I said that when that SHA is computed, the Git's database has a key value pair between the SHA and the content, right? So that information is linked to your commit. So when you say tree and there's a SHA to it, right? This SHA has a content linked in the database, and that content is nothing but the file name and its SHA. Are you able to understand? Yes, no, don't know? Hello?
Yes.
Yeah, great. So yeah, so that's how an anatomy of a commit is. All right. So you have links to each commit, and it goes on. All right. So what is a branch? And in Git, a branch is a simple, lightweight, movable pointer to one of the commits of a repository. So when you perform a commit, the branch pointer moves forward automatically. All right. So as I said before, when you say git init or say git clone, a master branch is automatically created for you. You are aware of that, right? So in Git, this is a default branch that has been created whenever you say git clone or when you say git init. So when you want to create a branch, you're basically creating a new pointer again, all right? And the command to create a branch is by saying git branch and the name that you want the branch to have. So what will happen is when you are on master, say you're here, all right, and you want to create a branch, you just say git branch testing and it will create a branch at this pointer itself. All right. So let's say when we start to, when you want to start working on some experimental features of the code, we would like to test without the risk to break the master code currently in production. So the best thing to do is create an ad hoc branch for that particular change, right? So that's how you create branches. So there's another special pointer in Git which is called the head pointer. All right. So whenever you say, whenever you have said git clone or git init, right? You don't just have a master pointer pointing at the latest commit, but you also have the head pointer pointing at the latest commit. Now you might ask a question saying that in this slide, okay, I have said git branch testing. Okay, I've created a branch here. Now how do I know which branch is my am I pointing to, right? It could be master or testing, right? So that differentiation is basically done by the head pointer. All right. So the special head pointer is used by Git to know on which branch currently it is. As you may see the picture, creating a new branch doesn't automatically switch to it. We are still on the master branch. All right. So when you use the command, the git log -and decorate option, this will basically give you some useful information. So when you say git log -online and -decorate, it basically gives the information of the existing commit in the repositories. Okay, so here you can see at F30AB is showing the pointer as head and master and testing, right? So this basically means that the pointer is the master is basically the head is pointing at master essentially. All right, so whenever you want to switch between branches, you basically use the command git checkout the branch name. So when you do this, if you see the head pointer was over here at master, right? So that gets moved to testing, and this is how you basically switch between each branch. Just give me a minute. Oh yeah, we just have 7 minutes left. Okay, I'll just try to finish branching at least for today, and we'll see if we can have another session for half an hour maybe tomorrow. If that's okay?
Yeah.
Right. Okay. All right. So committing to a branch. So if we made some modifications to the local repository while on the testing branch and commit them, we are going to end up in a situation, as depicted here. So earlier the pointer head and the branch testing was over here, right? So when you have committed a commit on top of it, both the branch and the head will move to the latest commit. Okay. So the testing branch has moved forward as expected, but the master branch is still pointing to the commit it was when we triggered the git checkout command, right? So git checkout branch name is different to SVN checkout. I hope we are aware of that, right? Okay. So diverging branches. Let's say that while working on experimental features, on the testing branch, a critical issue of a code currently in production is discovered and must be fixed with the highest priority. So we obviously need to switch back to the master branch to start working on the fix. All right. So when you say git checkout master, the head start pointing to the master itself, right? So the head pointer is rewinded to an older state, and we can start working on the master branch as we left before. So finally, when you made a fix in production for the bug that was created, a new commit ID has been created for that, right? So the point here is that using the branch, we are able to preserve multiple statuses of code as each branch is completely insulated from each other. So this is the beauty, of branching. By just using git checkout command, you can move out of, your testing branch to working on your production bug fix in a matter of like milliseconds, right? So that's the power. That's the power of Git. All right. So since switching back and forth between branches is as easy as launching a command, this is extremely powerful feature to use. Yeah, so one more point about branching. So there's a very important fact to never forget while working with multiple branches is switching between branches will actually modify the content of the working directory. So what essentially means here we mean is when you are working on testing, for example, okay, let me go back here. So imagine you're working on testing and you basically had some changes here, all right, and you did not save them. Okay, or say you do not commit them. If you shift from testing branch to master branch, you will lose those changes that you have made on the testing branch. All right. So there are ways to save those, changes, but then if you ignore it and just say git checkout, Git will warn you to that your changes will be lost. But if you continue doing that, your changes will be lost forever. All right. So yeah, this when you make a change, okay, yeah. So this means that if you have some uncommitted changes into the branch, when you're leaving, they will be lost forever. All right. Okay. So any questions you have till branching? The next topic is merging. I think we are almost time, so I can pick this up tomorrow if you guys are comfortable with the same time.
Yeah.
So yeah, I have a question about the branching. Just
Sure.
you mentioned that if we switch, we will lose the change. So this change will be lost even if it is there in the stage area.
Yes.
Okay.
So there's something called git stash. So that's the command that you can use to save the changes that you are supposed to commit or you want to commit to the staging area or to the repository. So so a stash ID is created and that will be pushed into another buffer, and then you can move to whatever branches you want, finish your bug fix in production, and you can come back to your testing branch and say git stash pop, and it'll pop out that particular change that you left out from, and you can continue development after that.
Okay. Okay.
So yeah, those commands I've covered in the future slides. Maybe we can go through that tomorrow.
Yeah. So yeah.
Okay. So any other questions we have so far till branching?
No.
Great.
Okay. Yeah.
All right.
So Azher, I think yeah, we will plan for another session. So see to cover whatever is left.
Yeah.
So we have also recorded this session, and we'll record the other one also, so that if someone is not able to attend that, can also go through the video
Sure.
recording. Yeah. And thank you very much, Azher. So I hope that whatever you explained in very detailed level is useful. And if you ask me, yeah, I now I'm getting why Git is considered different to SVN. The concept, yeah. Though yeah, I need to work more on that, but yeah, definitely it was useful for me, and I hope it is useful for others also. So
Yes. Thank you. I'm sorry, this is my first time I'm delivering a session this way, so I'm pretty sure I was nervous and skipped a lot of stuff. But then I hope it'll be useful for all of you.
No, thanks, Azher. You have done a fantastic job. So I
Thank
like
you,
it.
sir.
I like
Thank
the
you so much.
presentation. So and you are pretty nice. Your voice was good, and you are instant. So it's good. Keep it up.
Thank
And
you, sir.
I'll also like to thank the Chinese team over here. And now it is already late, and also the Israel team. Now I think it is too late for you. You must be starving. So thanks for joining, and we'll have a separate session from Azher sometime sometime tomorrow. Is it, Sandeep? When you are planning for the next session?
yeah, we need to talk basically. I will just
Okay.
check with
Yeah. So
Mike
so
and
stay
Yellow.
tuned. Stay tuned, and Sandeep will get back to us by when we'll have the next session.
Sure.
Okay. Thank you very much.
Thank you very much.
Thank you.
Bye.
Bye bye.
Thanks, Azher.
You're welcome.
Yeah, bye.
Thank you.
Thank you, Azher.
Thank you.